Hi, my name is Todd Wenty, and I am the other Associate Dean. Some of you may have heard my voice once or twice. For some of you, this may be the first chance that we're having a chance to get acquainted, but one way or another, it's nice to be able to introduce myself and nice to be able to take a few minutes to share a little bit of a training with you. Hopefully, you will find this valuable, engaging, and a little bit of fun. So my first question for you all is, what do you think of when you hear the word snowflake? Go ahead, type into the chat bar. I know I'm not there to read it, but I'm sure some of you are thinking some things that might be shareable with each other. Go ahead and type those into the chat bar. If you're like many people, you might be thinking about people when you hear about snowflakes, and some of you might be thinking about frozen water vapor. But whether you're thinking about people or frozen water vapor, I've got a video that might be worth watching and that we might be able to have a little bit of a discussion about. So if you'll stay with me real quick, we're going to watch a little bit of a video here.
You are a beautiful and unique snowflake. You are not a beautiful and unique snowflake. No one else is exactly like you. You're one in a billion. You realize that means there's like 8 people exactly like you? Shut up. I am a unique snowflake. That's so cheesy. There's a lot of snowflake science videos out there on YouTube, and they all mention the same idea, that no two snowflakes are alike. But where do we get that idea? The universe is a big place, it's really old, and countless planets with countless snowflakes, surely 2 of them have been alike. The idea that no 2 snowflakes are alike probably started on January 15th, 1885 in Jericho, Vermont. A 20-year-old named Wilson Bentley was sitting outside his farmhouse, freezing his Bentleys off, holding a sheet of black fabric and a turkey feather in the other hand, waiting for a snowflake to fall in just the right spot. And when it did, he put that snowflake under a microscope attached to an enormous old camera, and he held his breath. One wrong breath could ruin the whole thing. He opened the shutter, and Wilson Bentley had the first photograph of a snowflake ever taken. Wilson Bentley, seriously loves snowflakes, in the sense that he never got married, never moved out of his mom's house, and basically just took pictures of snowflakes for 50 years. Now, he called them masterpieces of design. Of course, we know there is no design in a snowflake, but that doesn't make them any less amazing. Every plate, every branch, every needle on a needle on a needle, all of those details are what's called emergent properties. This is complexity that's based on very simple rules. And for snowflakes, those rules go back to the basic laws of physics. In the air or in liquid, water molecules are zipping around, bouncing off of each other and everything else trillions of times per second. We have no way of knowing where they are or what direction they're facing at any moment. As we remove heat, it gets colder, and those water molecules start to slow down. Eventually, their atomic attraction, the actual hydrogen bonds between water molecules, takes over, and they settle into order. It sounds complicated, but we just call that freezing. The structure of a snowflake can be found in just 6 water molecules. I know that the angle between any 2 hydrogens is about 105 degrees, and I know that's true for any water molecule in the entire universe. And for some of those water molecules, well, the other hydrogen's behind them. Just like that, we've uncovered the 6-fold symmetry of a snowflake crystal. That crystal starts as a tiny speck of dust or pollen which catches water vapor out of the air and eventually forms the simplest of snowflake shapes, tiny hexagons called diamond dust, and then randomness takes over. There's a very simple reason why a snowflake's arm grows out here and not here. It's just because it sticks out farther and has a higher probability that water molecules will land there. And more water molecules and more water molecules land. And then we've got an arm and another arm and another arm and on until we get the intricate and beautiful shapes that we know and love. Depending on temperature and humidity, and a lot of factors that scientists don't even understand, those simple hexagons can give rise to seemingly infinite shapes. And each snowflake will travel through different air currents and bump into different water molecules. But in 1988, researcher Nancy Knight claimed to find 2 identical snowflakes, and they do look very much alike. It's quite possible that two of those simple hexagons could be the same in every measurement of size and mass, but they would not be identical, and physics tells us why. We know that water molecules are made of two hydrogen atoms and an oxygen atom, but not every hydrogen is created equal. If we go back to the Big Bang, we find out that out of every million or so hydrogen atoms created, a couple hundred of them, instead of just being a proton and an electron, are holding on to a neutron. And this is the isotope of hydrogen called deuterium. In Earth's water, even in you, about 1 in 3,000 molecules will be holding on to deuterium instead of hydrogen. Out of the million molecules that make up a snowflake, a lot of them will be holding on to deuterium too. Even identical looking snowflakes are not the same. Now,
So with that said, I'm going to stop the share for just a moment, and I'm going to ask a question. And this is a question that I would actually like all of you to have a little bit of discussion about. You're welcome to post your answers into the chat room, or you can shout it out loud if you've got permission from the host of the meeting. But I'm going to ask you to take about two and a half minutes to talk about each one of these two questions. The first one is, what conclusions could we draw about the similarities of our students to snowflakes? The second question that I'm going to ask is, how might this influence the way that we deal with our students individually and collectively? Again, the questions are, how might we take some of this information and have some similarities between snowflakes and our students, and how might those similarities between snowflakes and our students influence the way that we deal with our students individually and collectively? We'll give you about 5 minutes to discuss this via the chat room and via some discussion there. Go ahead and stop the video here, and we'll be back in a second. Okay, hopefully you've had a chance to have some conversation about this. As much as I'm sure you guys have come up with some great ideas, let's hear what our host of the video has to say about this. I'll go ahead and share our video again.
you could love a snowflake just because it's pretty, but it doesn't take away from its beauty to understand that it was sculpted by chance and physics. To me, that adds to the beauty. I have to say, this whole "we are unique snowflakes" thing is pretty cheesy. It might be the most overused metaphor in the history of metaphors. So, let me give you a new one. Snowflakes are symmetrical, but they're not perfect. They're ordered, but they're created in disorder. Every random branch retells their history, that singular journey that they took to get here. And most of all, they're fleeting and temporary. Even if sometimes they don't look so unique on the outside, if we look within, we can see that they're truly unique after all. Stay curious.
So with that said, I know that I have been thinking about this an awful lot over the last couple of days, and I just wanted to say that I love this idea of perspective. You know, sometimes hearing people use that phrase, "I'm a snowflake, I'm delicate, I want to be unique, I want you to treat me as though I'm unique," all these kinds of things, it can be a little bit wearing down, but I love the idea that, you know what, yeah, even when situations look like they're similar, they are different. And maybe that change in perspective can help us all be a little bit different. I know for me, one of the things that I took away from this video as I was watching it is that it wasn't so much about the delicateness, the fragileness, or the uniqueness of the individual. It was about the rarity of the time, about the short time period that we have in which to impact somebody's life. In the same way that a snowflake exists for a very short period of time, the window of opportunity that we have to influence a student's life and to help them start making choices and change their lives for the better is a very, very narrow window. It's precious, and perhaps we should treat it more like it's a precious thing. My name is Todd Wente. This has been my pleasure to be able to spend a little bit of time with you guys. Hopefully I'll get a chance to chat. We'll get a chance to chat more about this in the coming year. In the meantime, go forth and conquer, and I'll turn this back over to whoever is the host right now. Thanks very much for your time.